Now we're going to look at a different method for solving systems. It's called the substitution method. Our key terms: number one, non-graphical methods for solving systems of equations are called algebraic methods. One way to solve a system of two equations is to substitute an equivalent expression for a variable into an equation. If neither equation of a pair has variable alone on one side, we solve one equation for one of the variables. And sometimes it is easier to translate a problem into two equations in two variables. So let's look how the substitution method would work. When we're dealing with substitution, what we want is to see an isolated variable, or a variable, an x or a y all by itself. If we have that, and if y equals all of this, x plus 8, that means wherever I see a y in my other equation, I can substitute. This is going to give me a brand new equation. So I have x, and instead of y, I'm going to replace that with x plus 8 equals 12. What this does is it gives me a single equation with one variable, and if there's only one variable, I can solve it. The parentheses in this situation don't really mean anything. I'm just showing you that the group x plus 8. So all I have to do is combine like terms. So x and x is 2x. And now I just solve for x. And it looks like that x is going to end up being 2. Now recall that our solution is an ordered pair where our two lines would intersect if we were to graph them. In other words, I only have half of my answer. So to get the other half, to find my y, I take either equation, doesn't matter which one, just pick one. I'm going to pick the second one since it's already y equals and I'm looking for y. I'm going to plug in, instead of x plus 8, I think x is 2, so I'm going to plug in 2 for x, which gives me 10. So it looks like my solution to the system is 2, 10. Now you could always check your work by plugging in the values. So to check your work, if you're saying that 2 and 10 is your ordered pair, then our first equation of x plus y, so that would be 2 plus 10 equals 12, and that's true. The second equation is y, so it would be 10. Does that equal 2 plus 8? And that checks as well. So you can always plug in your ordered pair into both equations in order to check your work. Let's look at another one. Remember, we have to have an isolated variable, either x by itself or y by itself. We don't have that in either one of these equations. So we have 4 options. I can get this x by itself, or this y by itself, or this x by itself, or this y by itself. And you could do whichever one you like. I think the easiest one to probably get by itself would probably be this y down here on the bottom. So that's the first thing I'm going to have to do. So I'm going to rewrite this equation, and I'm going to isolate my y. Once I isolate my y, then I will be able to substitute it into the other equation and continue solving the system. So it looks like y is going to equal negative 2 plus 4x. So now that I know what y is, I can take that and I can plug it into the other equation in order to find my solution to the system. So let's go ahead and do that and see what we get. So I'm going to have 3x plus 2, and instead of y, I'm going to replace that with negative 2 plus 4x equals 1. This is going to give me an equation to solve. I have to distribute my 2, so negative 4, and then I'm going to have 8x equals 1. That's going to give me, I can combine like terms, and now I can start solving. So it looks like x is 5/11. Let's look at one more. Let's isolate. The easiest one to probably isolate is going to be the a in the bottom equation, because all I do is add b to both sides. And that would give me a equals 1 plus b. And then I could substitute all of that into the top equation for a. So now when I do that, I get 2b minus 3 times 1 plus b equals 0, and now I can solve for b. I'm going to have to distribute my negative 3, so that's going to give me negative 3 times 1 is negative 3, and negative 3 times b, negative 3b. Combine my like terms. I have 2b minus 3b, that is minus b minus 3 equals 0. Add 3 both sides. That gives me negative b equals 3. And I have to divide both sides by negative 1. That leaves me b with negative 3. Now let's find a. I'm going to use the bottom equation. Looks a little bit simpler to work with. So a minus minus 3, that's really a plus 3. Now I subtract 3 from both sides. It's going to leave me with negative 2. So it looks like my ordered pair is negative 2, negative 3. When they don't use x, y, put your variables in alphabetical order, and that's going to give you your solution.